Have you ever wondered how YouTube knows what videos you like? Have you ever think how Instagram knows which reels you like the most? Actually, it secretly groups millions of users of common interest. It's like games in one group, music lovers in another group, food lovers another group, and students also in another group. Do you know this grouping idea is one of the most powerful mathematical concept, and it is known as set theory or set. Set is defined as collection of well-defined objects. So it is defined as collection of well-defined objects. Here the word well-defined is very important. In set theory, well-defined means distinctly presentable. Let us understand this concept using two examples. If you are asked to write down a set of tasty foods, then can you assure that each one of the school will write same items or same foods in that particular group? You cannot assure that because everyone may like different foods. It is a qualitative characteristics of human beings that we have our own choices, likings, right? Now, next example. Suppose you are asked to write down the vowels of English alphabet. So, vowels are A, E, I, O, U. Here I can assure that every single person you meet in your town, everyone can tell you that vowels of English alphabet are A, E, I, O, U. What is the difference between these two? First one is based on qualitative characteristics and the second one is based on distinct and well-defined characteristics. These are well-defined. Each item in this particular group are well-defined. So we can say that set can explain those items which are well-defined or distinctly countable. Set cannot define items which are based on qualitative characteristics. Elements of set. Objects inside a set are known as elements of set. Objects inside a set are known as elements of set. So we have to know how to write a set. Set can be written with a name, and normally we give the names with the capital letter of English alphabet and we write down the elements inside a pair of curly bracket. In this case, let us take the previous example. Set of the elements of the vowel of English alphabet. So, we will write vowels A, E, I, O, U. So, how we can define set? What are these? These are now element of a set called set A. You can see that name of the set is written as capital letter and the element inside the set normally we write with small letter and separating each element by comma. Now, the next question arises, is this the only method to represent a set? Next is representation of set. Now learn how many ways we can represent a set. Normally there are two ways we can represent a set. The first one is known as roster form or tabular method. Or tabular method. First thing that you are sitting on a study table with a pen, a book, a copy and with a pencil box. So, if I want to represent all these items as a set, what I have to do? I will write book, pen, copy, write down it inside two curly bracket and I'll give it a name, suppose B. So, when we exhibit all the items of a required collection, then that method is known as tabular method or roster form. The next method is set builder form or rule method. Set builder form or rule method. In this method, we normally discuss the property of a set. That means based on which property a set is formed. Again, let us go back to the first example. Vowels of English alphabet. So, in this case, all the elements, that is A, E, I, O, U, these elements is popularly known as vowels. So, vowel is the property of all these 5 elements. If I have to write down these elements as set builder's form, I will have to write down only the property, only the rule that actually followed by all these 5 alphabets. We will write it in this way. Let us take C is the set, then we will give a curly bracket, X. Here X is not an English alphabet. X representing a variable. That could be any name, any number, any alphabet, anything. So, X such that this particular symbol, it is known as or read as such that. Okay, so such that looks like this. X such that X is a vowel of English alphabets. Okay, so this is how we can write any set in set builder's form. Let us write down a set in both the form. Number 1, N. N represents natural numbers, and in case of set theory, we can write natural number as 1, 2, 3, 4 and it goes up to infinity. Natural number always starts from 1, so the first element is 1 here also. Now, if I have to write down this set in set builders form, because this is what? Tabular method. So what will be the set builders form or rule method? We write it in this way. X such that X is a natural number. Suppose P is a set where P is representing 2, 4, 6, 8 and it goes up to infinity. 10 as tabular method. And if I have to write down the same set in set builders form or rule method, what should I write? I'll write it in this way. X such that X is an even number. Only writing X is an even number is incomplete information. We can see that all the numbers are positive. That means they all are positive integers. Rather, we have to say that they are natural numbers or positive integers. So, we could write it after this, putting a comma. X belongs to natural number or X belongs to positive integers, putting a plus sign. Now, here this symbol, it is known as belongs to. So, whenever one item is, we say that that particular item belongs to that set. This is how we can represent a same set in two different ways. Before going to next part, let me tell you what we learned till now. We learned that set is a collection of well-defined items. These well-defined items follow some rules when we need to represent them. The first rule is roster form or tabular method. The second is set builder form or rule method. In this case, we exhibit all the items one after another, separating them using comma. In this case, we only take the property a collection has. So these are the two different methods with some different methodology to represent a set. Next topic of discussion is types of set. Number 1. The first one is finite set. A set having limited or countable number of elements are known as finite set. Limited or countable number of elements. So, for example, 1, 2, 3. How many elements are there? There are 3 elements. This is also known as cardinal number. Cardinal number is the total number of elements a set has. So, to find out cardinal number, a set must be a finite set. Next set is infinite set. A set having unlimited number of objects is known as infinite set. So, we get unlimited number of elements. That means we cannot count the total number of elements in this set. So, in this case, we cannot find out cardinal number. For example, set of natural numbers 1, 2, 3, 4 and it goes up to infinity. So, you can see that there is no ending number. Set of integers. It comes from minus infinity, then minus 3, minus 2, minus 1, 0, 1, 2, 3 and it again goes up to plus infinity. These type of sets have no ending points, so they are known as infinite set. Do you know there is a set which can represent nothing? Yes, again I repeat, a set which represent nothing. Our next set is known as empty or null set. This is one of the most important set in mathematics and very special set. A set having no element or having nothing is known as null set or empty set. So, a set having no element or empty is known as empty or null set. For example, x such that x is an odd number divisible by 2. No such number exists which is an odd number and at the same time divisible by 2. So this set is known as empty set. How to represent an empty set? Well, we can represent an empty set by putting 2 curly brackets and inside nothing, or we can represent an empty set by a Greek letter phi. This one is known as phi. If I am writing b equals to phi, it means that b is a null set. Now, after these 3 types of most important sets, now we have to discuss about two more type of sets. Number one is equivalent set. So we have a set whose elements are 1, 2, 3 and 4. So it's a finite set. So you can write down NA means cardinal number of A is 4. Let us take another set B, and set B, let us consider the elements are A, B, C and D. In this case also, this one is a finite set and cardinal number of B is also 4. So, in this case where the cardinal number of A is equals to cardinal number of B, we could say that A is equivalent to B. That means number of items or number of elements or objects may differ, but if the total number of elements in both the cases are same, then two sets are known as equivalent set. Equal sets. So, now in this case, what is going to happen? Suppose we are having a set A, and set A is A, B, C and D. Here, cardinal number is 4. Let us take another set, set B. We are having the element B, C, D and A. So, here also cardinal number of B is 4. Now, in these two cases, what is the most interesting part? We can see that all the elements of set A are same in set B. Same element in both the cases. So, when two sets are having equal number of elements at the same time, elements are same, then we can say the set A is equals to set B. So, this is what? Equal set. Now, before going to finish today's video, let me tell you what we learned in type of sets. In type of sets, we learned that a set can be finite. That means whose elements are limited or countable, or a set cannot be finite. That means they are infinite, whose elements are unlimited. In case of finite set, we can count and write down the total number of elements. In case of infinite set, we cannot find out how many elements are there. Next, we learn about a set which has no element or nothing. In mathematics, nothing is defined as phi. A set which has no element or empty is known as phi, and it is also known as null set. After these three definitions, we come to know that there exist two more type of sets. One is equal, one is equivalent. Today we discuss what is set, how we represent set, what are the different types of sets. In our next video, we will discuss the application of the definitions of set and types of sets. Till then, stay with us and don't forget to like, share and subscribe our channel. Bye.